Earth is approximately 4.54 billion years old, making it one of the oldest surviving records of planetary evolution in our solar system. From its violent formation to the delicate balance that sustains life today, Earth's history is defined by continuous transformation. Over immense spans of time measured in millions and billions of years, physical, chemical, and biological processes reshaped the planet again and again. Mountains rose and eroded, oceans formed and disappeared, and life emerged from simple beginnings into complex ecosystems. Every stage of Earth's past left traces that scientists study through rocks, fossils, and planetary physics. In this documentary, we explore Earth's history in 15 minutes, tracing how a lifeless world evolved into the planet we know today. And if you enjoy documentaries like this, subscribe to WonderDoc Studio for more in-depth stories of our world. Did you know? If Earth's entire history were compressed into a single 24-hour day, humans would appear only in the final few seconds before midnight. Earth formed around 4.6 billion years ago within a rotating disk of gas and dust known as the solar nebula. Small solid particles collided and stuck together through a process called accretion, gradually forming larger planetary bodies. As Earth grew, repeated high-energy impacts released immense heat, keeping much of the young planet molten. During this chaotic period, temperatures were so high that solid rock behaved like liquid. Asteroid impacts were frequent, reshaping the surface again and again. During this early phase, Earth experienced frequent collisions with other protoplanets, including a massive impact around 4.5 billion years ago that likely led to the formation of the Moon. The debris from this collision eventually coalesced into a stable satellite, influencing Earth's tides and rotation. The intense heat caused heavier elements such as iron and nickel to sink toward the center, forming Earth's core. Lighter materials rose outward, creating the mantle and crust in a process known as planetary differentiation. The movement of molten metals in the outer core generated Earth's magnetic field. This magnetic shield later protected Earth's atmosphere from being stripped away by solar radiation, a fate suffered by Mars. As the solar system stabilized and major impacts became less frequent, Earth slowly began to cool. From chaos and collision, a structured planet started to take shape. During the Hadean and early Archean eons, spanning roughly 4.5 to 3.5 billion years ago, Earth remained extremely hot and geologically unstable. Large-scale volcanism dominated the surface, releasing gases such as carbon dioxide, water vapor, methane, and ammonia through volcanic outgassing. This process gradually formed Earth's earliest atmosphere, which contained almost no free oxygen. The sky would have appeared hazy and hostile, unlike anything seen today. As radioactive decay within the planet decreased and surface temperatures fell, water vapor in the atmosphere began to condense. Rain fell continuously over thousands to millions of years, accumulating in low-lying regions of the crust. These rains formed Earth's first stable oceans, fundamentally altering surface conditions. Oceans absorbed heat, regulated temperature, and stabilized the planet's climate. Liquid water helped regulate temperature and enabled sustained chemical reactions to occur. Many scientists believe these early oceans became the birthplace of life itself. Meanwhile, molten rock beneath the surface cooled and solidified, thickening the crust. This process created early continental fragments known as protocontinents. Although plate tectonics operated differently than today, material was already being recycled between the surface and mantle. Despite harsh conditions, Earth had transitioned from a molten body into a planet capable of long-term stability. The basic physical and chemical framework for life was now in place. The earliest evidence of life on Earth dates back to approximately 3.7 billion years ago, found in ancient rock formations and chemical signatures. These first organisms were simple, microscopic, and lived entirely within the oceans. They survived in environments without oxygen, relying on chemical energy sources near hydrothermal vents. Life existed quietly, unnoticed yet persistent. Over time, some organisms evolved photosynthesis, using sunlight to convert carbon dioxide and water into energy. This process released oxygen as a waste product. Initially, oxygen reacted with dissolved iron and other elements, leaving little free oxygen in the atmosphere. These reactions formed massive iron deposits still mined today. Around 2.4 billion years ago, oxygen began accumulating in the air during an event known as the Great Oxygenation Event. This shift dramatically altered Earth's atmosphere and oceans. Many anaerobic organisms could not survive in oxygen-rich conditions and went extinct. However, oxygen allowed for more efficient energy use, enabling the evolution of complex life. Ozone formed in the upper atmosphere, shielding the surface from harmful ultraviolet radiation. Life was no longer just adapting to Earth, it was reshaping the planet itself. Did you know? Some modern microbes living near deep-sea hydrothermal vents may resemble Earth's earliest life forms. By approximately 600 million years ago, life on Earth began to diversify rapidly. This period culminated in the Cambrian explosion around 541 million years ago, when many major animal groups appeared at the fossil record. Trilobites, early arthropods, and primitive vertebrates emerged in the oceans. Predation increased, driving evolutionary innovation. Organisms developed hard shells, skeletons, and specialized body structures. These adaptations increased survival and left abundant fossil evidence. Marine ecosystems became increasingly complex and competitive. Food chains lengthened, and ecological roles became specialized. Plants later began colonizing land around 470 million years ago, followed by insects and early vertebrates. Roots stabilized soil, reducing erosion and altering river systems. This transition transformed Earth's surface, contributing to soil formation and increased oxygen levels. Forests expanded and altered global climate by drawing carbon dioxide from the atmosphere. Food webs became more interconnected across land and sea. Life spread into nearly every environment on the planet. Earth entered a period of unprecedented biological complexity and diversity. Did you know? Trilobites had compound eyes so advanced they rival modern insects. Earth's surface is divided into tectonic plates that have been moving for hundreds of millions of years. These movements cause continents to collide, separate, and reorganize. Supercontinents such as Pangaea formed around 335 million years ago and later broke apart. These shifts reshaped coastlines, mountains, and ocean circulation. Shifting land masses altered ocean currents and global climate systems. Some regions became deserts, while others turned into lush forests. At several points, Earth experienced mass extinctions that eliminated large percentages of life. The most severe, the Permian-Triassic extinction around 252 million years ago, wiped out nearly 90% of marine species. Massive volcanic eruptions released greenhouse gases, triggering extreme warming. Oceans became acidic and oxygen poor. Another major extinction occurred around 66 million years ago, ending the age of dinosaurs. A massive asteroid impact released energy equivalent to billions of nuclear bombs. Dust blocked sunlight, plants died, and food chains collapsed. Each extinction drastically reshaped ecosystems. Surviving species diversified into newly available ecological niches. Earth's history became defined by cycles of collapse and renewal. Did you know, when Pangaea existed, much of its interior was extremely dry due to lack of ocean moisture? After the extinction of the dinosaurs, mammals diversified rapidly starting around 66 million years ago. They evolved into a wide range of forms, occupying land, sea, and air. Whales returned to the oceans, bats took to the skies, and primates adapted to forest life. Evolution explored new possibilities. Earth's climate during much of this period was relatively stable compared to earlier eras. Forests expanded, grasslands spread, and complex ecosystems developed. Periodic ice ages began around 2.6 million years ago, reshaping landscapes and sea levels. Glaciers carved valleys and redirected rivers. These glacial cycles influenced migration, evolution, and extinction patterns. Despite environmental shifts, biodiversity continued to increase. Flowering plants, birds, and mammals became dominant. Food chains grew more balanced and resilient. Earth entered a long phase of relative ecological stability. This stability allowed intelligence and advanced social behavior to evolve. Did you know? Early horses were no larger than modern dogs. Modern humans appeared approximately 300,000 years ago, extremely late in Earth's 4.5 billion year history. If Earth's entire history were compressed into a single day, humans would appear in the final few seconds before midnight. In geological terms, all of recorded human civilization occupies only a few thousand years, a blink of time compared to the ages that shaped mountains, oceans, and life itself. Yet within this brief moment, humans developed tools, language, symbolic thought, art, and complex social structures at an unprecedented speed. Early humans migrated out of Africa and spread across every continent except Antarctica. They adapted to deserts, ice ages, rainforests, mountains, and coastlines, using fire, clothing, shelters, and cooperation to survive extreme environments. Stone tools evolved into spears, bows, and later metal weapons, allowing humans to hunt, defend, and reshape ecosystems. Around 12,000 years ago, the rise of agriculture marked a major turning point. Nomadic hunter-gatherers began settling in permanent communities, domesticating plants and animals. This shift reshaped landscapes as forests were cleared, rivers diverted, wetlands drained, and soils intensively cultivated. Agriculture supported population growth, but also introduced new challenges such as disease, social inequality, and environmental pressure. Human societies grew into villages, then cities, and eventually civilizations. Trade networks expanded, writing systems emerged, and technological knowledge accumulated across generations. For the first time, cultural evolution began moving faster than biological evolution. Beginning in the 18th century, the Industrial Revolution introduced large-scale environmental change. Coal, oil, and natural gas-powered machines, factories, and transportation. Burning these fossil fuels rapidly increased atmospheric carbon dioxide levels, altering Earth's climate at a pace rarely seen in geological records. Human activity now influences global climate systems, ocean chemistry, land surfaces, and biodiversity. Deforestation, industrial fishing, urban expansion, and pollution have driven species extinction rates far above natural background levels. For the first time in Earth's history, a single species intentionally alters planetary systems. Scientists increasingly describe this era as the Anthropocene, a proposed geological epoch defined by human impact. Earth has entered a new phase, shaped not by volcanic eruptions or asteroid impacts, but by human decision-making. The future of the planet now depends on awareness, responsibility, and the choices made within this brief geological moment. Earth's history spans more than 4.5 billion years of continuous change. From fire and collision to balance and life, transformation has never stopped. Every rock layer and fossil records a chapter of deep time. Humans are part of this story, not separate from it. The decisions made today will influence Earth's next chapter. The story of our planet continues, written slowly across time, space, and choice.